Let's find the volume of the solid of revolution obtained by rotating the region bounded by the graphs of the parabola y equals x squared, the line y equals x, and rotated about the line y equal to -3. So first we're going to sketch this region. The region, here's what parabola looks like in the second quadrant. We don't actually need it. We do need its part in the first quadrant. Here comes the line, and you can see that they intersect in two places. This is our region right in here. We can find the points of intersection by inspection, or set the right hand sides equal to each other. X squared equals x, x squared minus x equals 0, x times x minus 1 is 0, so x is 0 or 1. We just need the x coordinates of the points of intersection because we'll be integrating with respect to x. I'm going to go ahead and draw this region once again and see what we can set up here with the integral. So here is the region. Notice that that's point 1, 1. This is the point 0, 0. I'm bringing in the axis of rotation. The axis of rotation is the line y equals -3. So now let's see. This point is 3 units away from the axis of rotation. On the other side, 180 degrees later, it'll end up also being 3 units away, so it'll be at -6. This point, the second point of intersection, is 4 units away from the axis of rotation, so it's going to, let's say, end up here at -7. It doesn't matter that much. We just want to sketch a relatively nice reflection like that. Now, this is 1. Pick an x between 0 and 1. And the trick to this, always refer to the original region. The region 180 degrees later, the reflection, is just there to draw the washer. But that's it. All computations should be done off of the original region. So I'm keeping track of this vertical piece of the area. Here is what's going to happen to it 180 degrees into the rotation. As it sweeps through for the entire 360 degrees, what it will do, it will generate a washer that looks like that. We are interested in the area between these two circles right in here. That's the key to solving this problem, is this area between these two circles. Recall that when we have a washer, so we have an outer circle and then an inner circle, we're interested in finding the area between the two circles. It's very simple. Let's say the radius of the small circle, the inner circle, is little r, and the big circle is big R. The area between the circle is just a difference of the areas. The area of the big circle, pi big R squared, minus the area of the small circle, pi little r squared. Simplify this as pi times big R squared minus little r squared. That's what we want. We want to express big R and little r as functions of x. So let's take a look. When we go back up here, the big radius is from here to here. That's the big radius. So look at the center of this is on the axis of rotation. From the axis of rotation to the x-axis, we have 3 units. And then when we go further to complete the big radius, we go all the way up to the line. So we want to add 3 to the y-coordinate of the point on the line. The y-coordinate happens to be x, equal to x, because y is x. So the big radius is 3 plus x. Similarly, little radius, from the center here, we go up to the x-axis, that's 3, and then to the parabola, so it is equal to 3 plus x squared. That's the key. Once we find the big radius and little radius, we set up our integral. Our integral for the volume looks like the integral from 0 to 1, pi, big radius, that's 3 plus x squared, minus the small radius, 3 plus x squared, squared. So it's just that this right here is our big R, and this inside here is our little r. And dx gives it a little bit of thickness, so it's really a cross section of the volume. The integral acts as a sum of all these cross sections between 0 and 1, gives us the exact answer. So this is pi times the integral from 0 to 1. Let's expand 3 plus x squared. That's 9 plus 6x plus x squared. Carefully put this in parentheses. Minus 3 plus x squared is 9 plus 6x squared plus x to the 4th power dx. And we can simplify this. That's equal to pi times the integral between 0 and 1. 9 is cancel. We have 9 minus 9 cancel. 6x doesn't cancel with anything, so that's 6x. X squared minus 6x squared is minus 5x squared. And then minus x to the 4th. It's a very simple integral that's left for us. So this is pi times the integral of 6x is 3x squared minus 5/3 x cubed minus 1/5 x to the 5th, evaluated from 0 to 1. When we put in 0, of course, we get 0. So the answer really is when we just put in 1. So we have pi times 3 minus 5/3 minus 1/5. And so the common denominator will be 15. And we have pi in front. 3 is 45 over 15. 5/3 is 25 over 15. And 1/5 is 3 over 15. So 45 minus 25 is 20. Minus 3 is 17. The final answer is 17 pi divided by 15 units cubed. For more videos